the information age, the automobile is going the way of the horse and buggy. On today's digital journey, host John Gage joins Amory Lovins, Rethinking the Automobile.
Imagine a car that is lightweight and powerful, safe and energy efficient, then link it to a system of smart roads, to the internet, to satellite tracking systems. You're creating a nomadic network. This is not science fiction fantasy. This is a practical solution to the world's transportation problems, and it's ready to be built. I'm John Gage. Join me for this digital journey onto the nomadic network.
I'm a girl who happens to think that a brand new car is better than mink.
Excited?
Delighted. So glad I got invited.
Ever since the invention of the internal combustion engine, people have been talking about the car of the future. But automobile design has not changed fundamentally until now.
Now, the dream cars of tomorrow.
The car of the 21st century will be to today's vehicles what the Model T was to the horse. Amory Lovins and his colleagues at the Rocky Mountain Institute call it the hypercar.
The smaller, better, faster, cheaper kind of revolution that we see in electronics is now coming to cars, partly because we're going to make the cars a computer on wheels, not a car with chips. So being software dominated, they'll be very flexible, upgradable, customizable, and will do many intelligent things you didn't think a car could do.
The hypercar will have an internal intelligence system monitoring and coordinating every aspect of its performance. Components of this system are already in production, and more are being designed by leading automobile companies every day.
Within the car, there's what amounts to a local area network in which all of the sensors and equipment communicate through continuously improved software to provide an expanding array of functions and features and behaviors that you want.
This car practically drives itself. Want to try it?
I'd love to.
The car itself, of course, will have its address on the internet, both for your own communications and for its communications with the factory to keep it all calibrated and keep upgrading your software and making sure nothing's going wrong.
Through these links, the car will become a self-monitoring node on a wireless network. Networks of cars have successfully platooned in tests, demonstrating the safety and economy of systems which allow vehicles to automatically adapt to the presence of other cars on the road. Safety can be maintained even along high-density routes.
Once you have the sensors and software that are built into the car anyway for other reasons, it becomes much easier to integrate it with more intelligent transportation systems at any scale, whether it's sensing traffic flow and avoiding collisions with things in front of you or coming in from the side, or giving you information about what roads to use, what the conditions are up ahead.
The hypercar's communication network can not only prevent congestion, it can create incentives for driving when there's less traffic.
You don't need to stop and pay your money. It's done automatically by a debit to your account as you whiz through the gate. If you're doing that, then it's also straightforward to make the charge vary according to the time of day or the actual level of congestion.
Another cause of congestion is the use of large vehicles to move one person at a time. Like the smart shuttles in Los Angeles, hypercars, deployed as jitneys, could combine the efficiency of mass transportation with the freedom of the individual car.
People would say, I need to go here, and a hypercar would come to your house since they'd know within a few feet of where the car was. The dispatcher computer would say, stop at this address and pick up 2 more people, and you could make a public transport system that was totally flexible.
You contrast that with the standard car, which has a capacity utilization of about 4%. The rest of the time it's parked. You start to see why businesses that provide access or mobility services could do pretty well.
A green alternative to contemporary cars, the hypercar is designed to reduce cost of ownership, complexity of assembly, and environmental impact.
We are about to take off on the highway of tomorrow. Stand by.
is the world's largest industry on the edge of a massive transformation. Joining me today to discuss this issue, my two guests, Amory Lovins, co-founder and Director of Research for Rocky Mountain Institute, and Jim Showalter, the Director of Advanced Automotive Technology for Sun Microsystems. Amory, let me begin with you, because with 150 million passenger vehicles on the road in the United States, parked 96% of the time, it seems we've built some massive structure that's very inefficient. Can we make this entire system, not simply the car itself, but the entire system more efficient?
At every stage, it is so inefficient it just boggles the mind. Only about 1% of the fuel energy in the car actually moves the driver. That's when you're driving it.
99%'s lost?
99% is lost before it moves the driver. That is, 80 or 85% of the energy never gets to the wheels. And then about 95% of the mass of the car is the car, not the driver. You got to move all that car around to get the driver someplace safely. Well, this is obviously not very gratifying after a century of engineering. We need to do better than that. And then you go back into how it's made. We have more people actually selling cars than making cars. And the way it's made is, in a way, very impressive. It's the highest expression of the Iron Age, but it's a terribly wasteful process. And the whole concept of making this huge steel artifact that's going to sit there 96% of the time doing nothing, and then it often isn't where you want it, or it isn't having the attributes you want for what you want to do at the moment. And by the way, why are we doing all this driving? Well, because we mandate and subsidize sprawl. That's pretty stupid too. We ought to be already where we want to be, so we don't need to go somewhere else.
So in every segment of the transportation component that the automobile industry represents, in making them, in using them, in selling them, in every aspect, there are tremendous inefficiencies.
Oh, it's unbelievably wasteful.
And it generates the second largest industry in the world, namely the oil industry. Yeah. So those two together sound as if they're at the moment right now of a change. Now, Jim, you deal with all the huge automobile companies. Do they realize that something's happening? Are they investing deeply in the hypercar ideas and a new intelligent transportation infrastructure?
Yes, and evidence of that is the metamorphosis that the entire world automobile manufacturing industry is going through right now. I think there's a general global recognition that we're fundamentally in the most lucrative markets of, say, the North American and Western European market is fundamentally a replacement market. The new opportunities and growths are going to be in Brazil, South America, obviously China, Indonesia. These would be the new markets, and a new vehicle, a new product is going to have to be produced, and the new operating procedures globally will be that you will have to build where you sell. That is a change for the automobile industries. No longer will we have the luxury of, for example, to be able to import or build our product here and import it there. We're going to build it there, which talks about a new supply chain and many new concepts that are going to have to be implemented in the automobile industry.
Now, are the Chinese, as an example, leapfrogging the existing methods of production, the existing design components? Amory?
Yeah, this is starting to happen. In fact, in early '99, a 50-year-old company, Huatong Motors in Sichuan province, is going to be ramping up initial mass production of an all-molded polymer composite hybrid electric car called the Paradigm, designed by a little firm in Texas. There's another joint venture operating out of Singapore that will be making a variety of thin-walled stainless steel tubing space frame vehicles with Velcro-on plastic panels. That could well be a hybrid drive. There are a lot of interesting projects popping up around Asia where manufacturers are starting to say, I don't want to be one of those steel stampers in a crowded commodity market. I'm going to strategically distinguish myself and do something completely different. And it makes sense also in the industrialized countries. I mean, think about it. Cars have stagnant fundamental innovation. Henry Ford would recognize practically everything in a car if he woke up today. They're a cutthroat competition commodity item fighting for microscopic niches in saturated core markets. In other words, this shows every sign of the kind of over-mature product that, say, typewriters were just before computers arrived.
In China, the small car, the Paradigm, made of a molded a polymer body, What's the advantage of a polymer body for a car manufacturer?
The number of parts in the body can be anywhere between roughly 2 and 20 rather than hundreds. You need one die set to mold each part rather than an average of 4 to stamp steel progressively into the shape you want. The tools can be very cheap, molded out of the same material you're molding, like, say, coated epoxy, rather than having to have 1,000 engineers spend about $1 billion in a year designing and a year building a football field full of car-sized steel dies. And then you have to make a huge number or you go broke because you haven't paid for the tools yet. So it's a radically different business. You get up to a tenfold decrease in capital, in the time it takes from concept to street, the assembly effort and space, the number of parts. The car gets radically simplified, and it's ideal for any manufacturer, even quite a new one that couldn't enter the market at high prices, to jump in and leapfrog over everybody else that's still paying for their old tools and equipment.
Now, we've watched the American manufacturers respond to the Japanese push in quality with better and better existing manufacturing processes. Does this mean that what they've done, in some sense, will be jumped over, bypassed by new production techniques?
The automotive OEMs, original equipment manufacturers, are taking very large steps. For example, the harbinger of the new modern, I'll call it the 21st century automotive plants, are being demonstrated in Brazil today. And all of the majors are there, Volkswagen with their Plateau 6 project, Ford with their Amazon project, General Motors with their Blue Macaw project. Incidentally, all these projects are named after Brazilian national icons. But fundamentally, they're talking about this new notion of fractal manufacturing or component manufacturing. Once again, not unlike what we've seen in the computer business for quite some time. The General Motors of the world, the OEMs, the OEMs as we know them, perhaps we'll get to the point where they are simply providing the shell, and the suppliers are filling the shell.
And indeed, when you go to a polymer composite car, you could imagine a rail car full of polyacrylonitrile pulls up and discharges that substance into a turnkey carbon fiber plant that's right there. Carbon fiber comes out inside the plant, you make it into a car, and cars come out the other end. And you don't need a whole steel industry upstream of that.
So you save tens or hundreds of millions of dollars in steel stamping
billions and
equipment.
billions, yeah.
And upstream, that transforms the steel and aluminum industries.
That's right. And of course, the more the car itself becomes a software-dominated product that implements in software a lot of what's now done in hardware, the more radically it gets simplified. You get rid of a lot of duplicate stuff, or parts go away altogether. I mean, just when the car gets ultralight, you don't need power steering or power brakes. You can have them if you want to, but you don't need them. And then when you go to a good hybrid drive, which gets practical because the car is so light and slippery, you get rid of things like transmission, clutch, flywheel, axles, differentials, drive shaft, U-joints, starter, alternator. A lot of stuff just goes away. We have this whole car industry based on mechanicals instead of electricals, and hardware instead of software, and hydraulics instead of electronics. There's all these revolutions we're going through at once, all condensed into a single generation's leapfrog.
For transcripts, multimedia files, and worldwide links, click www.djourney.com. For the practical visionaries at the Rocky Mountain Institute, there is no contradiction between meeting the needs of the market economy and drastically reducing waste and pollution.
A hypercar uses about 4 to 8 times less fuel than normal. It has 10 to 1,000 or more times less pollution than normal. In fact, it can have none at all. It has superior comfort, durability, safety, performance, acoustics, and therefore will be bought because it's a better car, not because it saves fuel and pollution.
These remarkable savings will come from the hypercar's hyper-efficient use of energy and materials. Carbon composite materials are used to construct the chassis of this prototype bus built for Los Angeles.
The basic idea in the case of a car or similar vehicle is to make it 2 or 3-fold lighter in weight than normal by molding it out of advanced polymer composite materials instead of stamping it out of steel.
A car that is made of polymer composite instead of metal does not need a massive engine. Lovins and his colleagues envision a hybrid propulsion system combining electric motors with fuel cells. Fuel cell buses are already on the roads in Chicago.
It doesn't need a very big electric motor to get it moving and to make it pass people. And if it's real streamlined, it doesn't need much of a fossil fuel engine to keep it going.
With its decentralized propulsion system, a hypercar can dispense with expensive and heavy parts which connect the engine with the wheels. Hybrid engines, as demonstrated in this Toyota Prius, combine the driving range of a conventional gasoline engine with the efficiency of electric.
The horsepower exhibit demonstrates how the new high-compression engines are longer wearing.
You power the wheels with special electric motors, but you make all the electricity on board from fuel as needed, because fuel has about 100 times as much energy per unit mass as batteries do.
A surprisingly big portion of a car's price is its transmission. And the hybrid car probably, as we're working on it, probably won't have a transmission.
The lighter the hypercar gets, the less equipment is needed to propel it, which allows the car to save even more weight.
As usually happens when you design a whole system, the parts start to work together to give you more than the sum of the parts. Vicious circles turn into virtuous circles. What you do to address or avoid one problem actually solves many more.
One problem is on almost every driver's mind: the chances of an accident. What will happen when an ultralight car crashes with heavy metal? Can the hypercar's shape, materials, and structural integrity protect its passengers in a collision?
Indianapolis cars are made of carbon fiber, largely, and you've seen pictures of them hitting the wall and the driver get out and run away. The car gives its life to save yours.
Barring a major crash, a hypercar should last much longer than the 20th century car does. Like a computer, the hypercar will improve its performance through new software without changing its hardware.
Just plug in new electronics and software, and it's more like an airframe than a conventional throwaway car.
In the age of the hypercar, it may be unconventional to own one. Instead of car dealers, there will be companies offering mobility. People may rent or lease the vehicle that suits their needs at the time.
If you want a sports car for a short jaunt on the weekend, you'd have that. If you want to haul all the neighborhood kids to a soccer game, you'd have that. In other words, according to your needs at the time, the type of mobility you need, whether by a car or by public transport, door-to-door van subscription service or whatever, would be arranged for you with no hassle.
Just as the automobile transformed the economy and landscape of the 20th century, hypercars are likely to shape the world of the 21st century.
Ultralight hybrid cars will probably make the biggest changes in industrial structure since microchips. We think they will be the end as we know them of the car, oil, steel, aluminum, coal, and electricity industries, and the beginnings of new ones that are more benign and more profitable.
Update your mind. www.djourney.com.
What other investments are needed for the rest of the transportation system? Global positioning satellites, smart roads. How much of a change in overall transportation efficiency can we gain there?
Huge. Just looking at the fatalities and the cost of accidents each year. Roughly 6.5 million accidents reported each year in this country. They cost, ultimately us, the consumer, $150 billion a year. A lot of this can be eliminated. Many lives can be saved simply not only through the better vehicle, but through a better system. And this is not to mention the whole problem and the growing problem of congestion. In the top, let's say 50, even the top 75 metro areas in the country suffer from gridlock at least twice a day. In some cases, it's continuous through the day. Through a better system, I'm going to call it perhaps an overused word of a collaborative system, not only with the smarts within the vehicle, but the smarts within the actual system itself, the actual environment.
Well, we see this in many cities when we climb into a taxi today, and we find that there's a modem and display on the dashboard that keeps the driver continuously dispatched to the nearest job, and you don't hear anymore all this chatter on the radio about, gee, is anybody near such and such a place who can go pick up Miss Jones? Well, you don't need that. Whatever taxi is near there is already dispatched. And we're doing the same thing with cargo now. We're getting much better at computerized logistics so that you don't have the same object being sent in opposite directions simultaneously.
How would this apply to the automotive industry? Would a car be returned to General Motors, back to the mother plant in Detroit?
Probably you would never have bought it from them. They lease it to you, they own it forever. And like an airframe, it comes back again. If it's a composite body which doesn't dent or rust, then it lasts essentially forever until you want to recycle it. So you can renew the color skin, which is a stick-on. If you're tired of blue, you can try a leopard skin or a Mackenzie tartan or whatever pattern you want. And you plug in new electronics and electricals and new software, which is always getting downloaded wirelessly anyway, so you always have the latest version. Also, it's very customizable. So what was originally a young man with excess testosterone mobile can also, with a few software tweaks, become a little old lady mobile or vice versa. It has the technical capability to be both, but the user selects the personality. And this means between changing a few external trim and color coat details and changing personality, you have the chance to sell it into different markets, or in different countries for that matter. So I guess eventually when it recycles through a number of markets, it gets retro and you bring it back again as a new fashion, kind of like an MG Midget reincarnated, so to speak, as a Mazda Miata.
Are we watching changes from this fundamental shift in the technology of the automobile radiate through urban design? Are we seeing a different use of streets? Are we seeing a different use of power supplies in the car to supplement power supplies from today's electric utilities?
Oh, this is a really fun possibility because, remember, the car is parked about 96% of the time. Now, in order to make, say, fuel cells the cleanest and most efficient power source we know, cheap enough to put in a hypercar, you're first going to have to put them in some buildings where their waste heat can provide building services that make it worthwhile, even at today's prices. But then as you build up the market in buildings, which use 2/3 of our electricity, the fuel cells get cheap enough and you start putting them in cars. Now, each hypercar powered by a fuel cell is a little, say, 20 to 40 kilowatt power plant on wheels. And suppose that you lease those cars first to the people who work in the buildings where you already installed fuel cells. And therefore you have a hydrogen source in the building that's not kept fully occupied all the time. So now you drive your car to work, you plug it in as you park it to the electric grid and the hydrogen source from the building. And now as you're sitting at your desk, your previously idle second biggest household asset is now a profit center because it's selling 20 to 40 kilowatts of premium, ultra-reliable power back to the grid at the real-time price. Remember, it's worth the most in the daytime. And that is earning you about enough money to pay half the lease fee on the car. Now, it doesn't take very many people doing this to put any remaining coal and nuclear plants out of business because the hypercar fleet will ultimately have about 5 or 10 times the generating capacity of the national grid.
So when I've driven my car to work and I'm in the office that I'm working in and my employer is buying electricity to cool my room, and he's buying it from me because my car is out in the parking lot generating electricity, quiet, fuel cell.
Silent, completely clean, there's no combustion going on.
The product from a fuel cell, it's hydrogen in, or a natural gas in, hydrogen in, hot water and electricity out. That's
Nothing else. Remember in high school chemistry, you did this little experiment where you use electricity to break down water into hydrogen and oxygen? A fuel cell is exactly the same thing backwards. Hydrogen plus oxygen makes electricity and hot water.
So we're seeing
pure water, astronauts drink it.
So it's the way we think about this. And it's interesting to me to watch the constraints that the engineers in the world's largest industry have seemed to feel were placed on them by the successful sales they were making.
I used to work for the inventor Edwin Land, who said people who seem to have had a new idea have often just stopped having an old idea. And in automaking, as in so many other industries, the hard part is letting go of this massive knowledge they've accumulated of the right way to build cars, because now there's a completely different way to build cars, calling on a different set of skills, but it's better engineering and it's so much more fun. Once they get into it, they don't want to go back to the old way.
I think back to the 70,000 kilometers of interstate highway system that was created started in the 50s. I would argue that completely changed the way where we live, the way we work. It was a phenomenally successful adventure, to the point where we have created enormous congestion problems in these cities. That has to be addressed, and it won't be addressed just by the car companies or just by the vehicle. Just replacing a one-to-one replacement of our current vehicles, a fossil fuel burning type of vehicle, with a hypercar.
You no longer run out of air or oil or climate. Instead, you run out of roads, lands, and patience.
Exactly.
It's the constraint du jour. So we need to have great cars and not drive them very much. And in order not to drive them too much, the best way not to need to get around is to be already where you want to be, right, which means sensible land use, so you don't need to go somewhere else. The next best method, as we're doing now, is just to move the electrons and leave the heavy nuclei behind, just have great telecom. Right. And probably the third best method is to move the protoplasm around, and there are a lot of ways to do that. Mm-hmm. Some involving other vehicles. Bicycles, including hybrid electric bicycles, are getting really interesting now. There are some ultralight trains that are 5 or 10 times cheaper than regular trains that are starting to emerge. There's the Curitiba bus innovations in Brazil. A long list of improvements to public transport. And then, of course, there are cars, there are jitney services, dispatch on-demand shuttles. Right. You know, lots of options besides just one person, one car.
So we've surveyed some massive changes taking place in the most fundamental industries of our world economy. And the political and economic meaning of this is very powerful, I think. So what seems to be the application of some elegant technologies fundamentally shifts the economic structure of the world. I'd like to thank my guests, Amory Lovins, Jim Showalter, for joining us. I'd like to thank you for joining us. For Digital Journey, I'm John Gage.
In today's society, information creates economic opportunity. On the next Digital Journey, host John Gage investigates bandwidth and the small community.
From the way companies process information to the way they share information. From the way they create ideas to the way they sell ideas. Secure old customers. Attract new customers. Use devices to extend their business. Leap ahead of someone else's business. At Sun, our technologies power the net for business. We're the dot in .com. What can we .com for you?